Hello ladies and gentlemen, this is video 5 of the day. My training got out a little bit early and I have just enough time to make one more tutorial video before I wrap up and finally eat. So, this is for Algebra 2 Goal 5. One of my students is particularly ambitious. He's a chapter ahead and he's trying to finish his credit before the whole kerfuffle debacle ends. The biggest point of concern is factoring redo, technically, because that's French. But the thing that we want to be doing for this is, let me fix the layer that I'm on. Highlighter layer up above. Okay, so these 4 topics here that I have highlighted, you're doing literally the exact same thing for all 4 topics. It's just a question of how the setup they give you gives you very slight nuance. So we'll start with the most basic of basics, factoring a univariate polynomial by grouping problem type 1. This is the easiest of the cluster of 4 because they basically low-key kind of hand everything to you on the silver platter. The whole point of factoring by grouping, and the reason why they say grouping, I'll zoom in a little bit, is there. By grouping is what they're doing. Whoops. Ms. Dubois didn't change her key. Let's try that again. The whole point, brush tool, is when they say factor by grouping, is that they're looking for you to pick 2 numbers, yoink them out, and look at them by themselves. Yoink them out and look at them by themselves. Now, what they do for this first version, univariate and type 1, is they give you everything that you need to group physically next to each other, so it's not a matching game. So for here, if I pull this out, my y cubed plus 4y squared. If I'm looking, I have y to the 3rd and y to the squared. That has a little amount of overlap because y to the 3rd is 1, 2, 3 y's. Y squared is just 1, 2 y's. So when I'm looking at them, how much do they have in common? 2 of them. So if I pull out a y squared, that becomes y plus 4. All right, so far so good. Now for this one, my 3y plus 12, what does it have in common? Well, one has a y and one doesn't. That's not particularly helpful, but the 3 and the 12, that's really interesting because they're both divisible by 3. So divide by 3, divide by 3, and hey, you know you've made it. Your win state is when your parentheses match. So I have a y plus 4 over here and a y plus 4 over here. That means I have y plus 4 as one of my groupings. And therefore my other one is, well, what's my leftover? Y squared. And what's my other? Plus 3. This then is the answer that you are putting into your answer box. So let's look at a different one. Again, this is the easy type. They give you the things you need right next to each other so you're not trying to mix and match. So if I'm looking at that, y cubed and y squared, again, it's the exact same setup as over here. I can pull out a y squared. That becomes y plus 4. Wait a second. It's the same problem, isn't it? These screen grabs, man, the software isn't nice to me, but let me walk you through it. Then 3 and 12, those are both divisible by 3, y plus 4. Matches, we're good. So we have y squared plus 3 parentheses y plus 4, and we're done. And you'll take note, my y squared plus 3 is listed second here, and then it's my first binomial here. That's to say that, and this is a throwback to a chapter 1 topic, this is called the commutative property of multiplication. The order of your parentheses doesn't matter so long as your parentheses match. So let's actually pick a problem that's actually different. So let's see here. We're going to look at these, and then we're going to look at these, now that they're all broken up. I have my y cubed and y squared, and we've done that, a couple of times. So we know we can pull out a y squared. And if you're looking to do this in fast mode, you always pull out your lower exponent. But what happens with the numbers? Because I have a 6 and I have a 10. Those are both even numbers, which means I can probably pull out a 2. So 6 divided by 2 is 3. Y divided by y is y. 10 divided by 2 is 5, and then y squareds cancel. So that one looks pretty good. I'm about as far as I can get with that one. Now I want to look at this one. Y, no y, we kind of saw that coming in. We have a 9 and we have a 15. Those are both divisible by 3. So if I pull out a 3, 9 divided by 3 is 3, and then 15 divided by 3 is 5. Do they match? Do they match? Do they match? Yes. So what do we have? We have 3y minus 5, and then 2y squared plus 3. Boom. There's my answer. One more for posterity to make sure that you're comfortable with this particular topic. Right there, blocked off, easy to point out. Right there, blocked off, easy to point out. This one, let's see here. I have the 7, but there's no match over here, but I can pull out an x squared, because again, you're pulling out the smaller exponent because that's what you have in common. So that would be x plus 7, okay? And then over here, I have a 5, and I have a 35, which means both of those are divisible by 5. When I pull that out, what do I have? 5 divided by 5 is just 1. 35 divided by 5 is 7. Does it match? Does it match? Yes. So we have x plus 7 and then x squared plus 5. There. So that's problem type 1. What does problem type 2 look like? Let's scroll down and have a look. It looks at a glance like it might not be that bad. It looks like the same thing, so let's do an investigation. So we're going to pull out here and here, and we're going to pull out here and here. So if I look at this, I can pull out the W4, right? W4, or W4, Ms. Dubois, know what you're writing, gosh darn it. W4, and then that becomes a 2W, and then that becomes, well, remember, W4, so if I W to the 4 and I pull out W to the 4, that should look awfully familiar from goal 3. We know that's going to be 1 because they completely cancel out. If I'm looking over here, I have the 12 and the 6. They match, which means I can pull out a 6. That gives me 2w plus 6 divided by 6 is 1. Does it match? Does it match? Okay, so this is exactly like problem type 1. I'm liking what I'm seeing so far. We are left with w to the 4th computer, w to the 4th plus 6, and then it's 2w plus 1 as our answer. So far so good. Why is this a type 2, I wonder? Looking over here, let's see here. Break that off. Break that off. So 4 and 10, those are both even numbers, so I can pull out a 2. Y cubed, y squared, we can pull out a y squared. 4 divided by 2 is 2. Y cubed divided by y squared is y. 10 divided by 2 is 5. Y squared disappears. All right? Now here's where it looks a little funny, because I'm looking over here and I don't see anything to be had in common. What can I pull out? Well, when in doubt, what's the default thing you can pull out? A 1, because I still will get me my 2y minus 5, because 1 times 2 doesn't change, 1 times 5 doesn't change. Does it match? Does it match? Ah, yes it does. So what do we have? We have 2y squared plus 1, and then 2y minus 5. So you can kind of see this is like problem number 6 of me doing exactly the same thing all the time. Let's go through a couple more. So if we're looking at this one and this one, 4 and 5, they don't have anything in common. X to the 4th and x cubed. I can pull out an x cubed, so that leaves me with 4 x to the 4th minus 3 is x to the 1st plus 5, because the x cubes cancel. And then what do I have over here? 28 and 25. What are those both divisible by? 7? So 7, that would be 4x, and then divide by 7, that would be 5. Do they match? Do they match? Yes, we're good. X cubed plus 7, and then 4x plus 5. So again, nothing is new. This is 7 and soon to be 8 problems where we're doing this, and we are not doing anything radically new or different. We're getting the same thing every time. The only reason why this is called a problem type 2, there we go, is because of problems like this and also this, because I'm going to explain in a second. Because you can see here, I had that extra, can I get a different color? Computer. Oh, come on, computer, you haven't overclocked all morning. Don't do this to me. Okay, I think it stopped. I've lost track of what I was saying. Let's see here. Why this is a special case, why this is problem type 2. If I'm looking over here, I can pull out my 3. Hang on, let me box these off. If I'm pulling out my 3, that's pretty easy. That'll be 3, and then it'll be negative x plus 1. Does it match? Does it match? No, it doesn't. But then what, in fact, is the problem here? Why is this being so mean-spirited to us then? The thing that's going on, if my computer will stop lagging, is that the signs are different. This is a plus when it's supposed to be a minus. Let's see here. This x is negative when it's supposed to be positive over here. So what this means is this is in fact wrong. It's not just the 3 we're pulling out, we're also pulling out the sign. And that's what they're trying to train you for problem type 2. Where problem type 1, it was same old, everything fell out together perfectly, there was no deviation. Here, they want you to be a little bit careful, to be a little bit more observant. And that's what's happening, is you're doing the same thing over and over. They're just very quietly ticking up the difficulty curve. So to wrap this up, we have, that's a minus, Mr. Barr, what are you doing? It is going to be x minus 1 parentheses x squared minus 3. All right, so that takes care of the problem type 1 and 2 for univariate. What about multivariate? So univariate means that there's one variable. Multivariate means that there's more than one variable. So now we're going to have 2 variables that we're trying to fight with, and oh god, the horror, except kind of low-key, not really. So if we're looking at this, again, this is problem type 1, so let's see how nice they are to us. Split it in half. 4 and 3 doesn't combine, but we can pull out a w, so that becomes 4 plus 3x. I like that. This one, again, it's the same stuff that we were doing over here. That's low-key exactly what we're looking for over here, so that means the only thing that I'm pulling out is a 1. So that's a 4, I promise. 4 plus 3x, 4 plus 3x, it matches, so w plus 1, parentheses, 4 plus 3x. That's what we're looking for. All right, here, again, we're going to break it down. And so far, we haven't had to do a lot of mixing and matching. 3 out of 4 of these topics, they've had them right next to each other. Let's see here. This, we can pull out a 3, 3s, and then N, P, R, R. We can pull out an R. So 3R, and that will get us, if I pull those out, that'll give us an N minus P, okay? And then if I look at this, I can pull out a 5, I can pull out a 5, so that will be N minus P. Does it match? Does it match? Yes, it does. So let's see here. We can have N minus P and then 3R plus 5. So it's the same old. Nothing has changed. It's a little bit more nuanced, but it's the exact same thing every time. That's what I'm trying to emphasize here. Take this one, break it down, cut it in half. We have the W and the W. So W is 2 plus U. All right. Here, this is again, they're pulling in the stuff that we did over here because I got to be careful of the signs. Here, everything was positive. Here, I have some negatives to take into account. So it's not just 6 I'm pulling out, it's negative 6, and that leaves me 2 plus U. Does it match? Does it match? Yes. So W minus 6, and then 2 plus U, and then we're done. And suddenly you realize that this is starting to be actually a confidence builder, all right? Now we look over here, split it in half. We have an x and an x, so if you pull that out, that's going to be u minus 7. Here, signs again, they're reminding you about this particular topic. It's almost like they're being subtle or something. Oh, wait, maybe not. So let's see here. I need this to be a negative, which means I need to do that to be a positive, which means not just am I pulling out 2, I'm pulling out negative 2. And then that will be u minus 7, because I pull out the negative 2, and then I pull out the negative 2. So does it match? Does it match? Yes. So what do we have? We have u minus 7 and then x minus 2. And I'm getting to the point now, this is going fast enough where I'm not even thinking all that much about undoing. And granted, professional math teacher over here, I get it. But as you start doing this, this is a good one to get, like one right, one wrong, because you fall into that rhythm of breaking it down. Now, problem type 2 over here, this is where things start to get a little tricky. Because up until now, brush tool, you just split it in half. They've been very nice to you. But if I look, 6y squared, 5x, there's no version of that that's going to meet the demands that I have here. which means now this is the one, problem type 2 with a multivariate, where you have to do some experimenting and mixing and matching. That's the part that makes this one a little bit harder than the other, 3 topics that we've been doing. Where my trained math brain is looking around, I'm starting to notice I want to kind of look for my bigger numbers. So I have the option of 5x and 30, because that 30 breaks down a couple of ways. Or I could pull out my 6y. I'm not sure which one to do yet because I am doing this blind. So for now, we're going to look at our 5x and 30 and see if we can make that work for us. So we have 5x plus 30y and then negative 6y squared minus yx. And now they're split up deliberately. I can pull out my 5, so that becomes an x plus 6y. All right, I like that. This one, let's see here, I can pull out a y, and I want my signs to be positive, so I'll pull out a negative y, and that leaves me with what? 6y, and then just x. Does it match? Does it match? Yes, it does. It doesn't look like it matches perfectly because you can see the x is in front here and the x is in back here, but again, commutative property of addition, this matches. So we're left with 5 minus y, and then I can use either one of these to fill in because it's the same thing. I'll do x plus 6y. So that was a little bit scary, and you can see that there's a higher curve here, but so far so good. This one, I'm liking that 12x. That's my biggest number, and it can divide a couple of different ways. I don't know which of these two that I want to do. Let's try the 2x squared this time. So we have negative 2x squared plus 12x, and then we have xw minus 6w. So let's pull these apart. I can pull out an x, and then I can pull out a 2. I'll make it a negative 2 to be safe, though, because I always kind of like my front term being positive. There's no particular reason for that, so much as Ms. Dubois is OCD and likes to have things look a certain way. So if I pull out a negative 2, that becomes, a negative 2x. That becomes x minus 6. All right, I like that. And then if I look over here, I can already tell w is the only thing I have in common. So that becomes w and then x minus 6. Wow, I'm doing this live without looking at these prior, and I'm getting them right on my first try. No, I've just jinxed myself. All right, so what do we have? We have negative 2x plus w, and then x minus 6. Or if you really want to live dangerously, we can do w minus 2x parentheses x minus 6. The computer will label them as right because, again, commutative property of addition. And now, ooh, I ran out of space. Oh no. All right, so I have the 14. That's the one I like. Do I want to use the x, or do I want to 2x, or do I want to use the 7y? We'll try the 2x. Okay, so 2x minus 14y, and then it'll be 7y squared minus yx. Okay, so we can pull out the 2, and that's really all we can pull out. So that will be x minus 7y. All right, and then over here I have the y's, which is kind of the only thing I can pull out. So that'll be y, and then it'll be 7y minus x. All right, no, it's not going to be like that because it needs to match the signs. So I did make a mistake live. So instead of this being y, it's going to be negative y. So that's negative 7, and then that will be positive x. Does it match? Does it match? Yes, it does. So I have 2 minus y, no space, and then it's x minus 7y. And there is our solution. Last one, what's my biggest number here? The 6u, that's the one I like. Let's see here, what do I choose? We will choose the 2u squared. So we have 2u squared minus 6u on one side, and then we have negative 3x plus ux on the other side. Let's see what's going on here. We're going to try, what do we pull out? We can pull out the 2, and we can pull out a u. So 2u, that becomes u minus 3. That's what I'm looking for. U and then minus 3. And I can already see x is the only thing I have in common. So that will be negative 3 plus u. and all I have to do is reverse that, and I have the exact same thing as this. So 4 times in a row, Ms. Dubois has somehow managed to get the right combination. So what do we have? We have 2u plus x, and then u minus 3. So don't be afraid for this topic to do a little bit for problem type 2 for multivariate. Don't be afraid to do a little bit of experimentation. I have done this topic enough times where there have been moments where I did not pick the right number and then I had to start from scratch. Do not let yourself be afraid of that. You are doing the exact same thing every single time. The only thing that's new about this particular topic is that you're reordering your numbers and you're picking which pairs you are using together. So that covers everything from this select of highlights. That should be a good starting case for family 3. Summer difference of cubes is a formula, quasi-formula you need. Roots of polynomials, if that's the topic I'm thinking of, is actually one of the easiest topics. This one tends to be a problem for kids, and it's also a DSA topic, so I will do that on my next video. In the meantime, stay happy, stay healthy, stay safe. See you in the next one.